All right, so just quick recap. What we've done is we just liberated the edge to make the data available in our broker. Okay. Now, the second part of Yaku's discussion around what do we need to actually have digital transformation is we now need to be able to get insights from our data. The only way that we can get insight from our data is if we have a proper data ops platform. Traditionally, how would you store this data, a TVQ, timestamp value quality? How would you store that for historical analysis? In a database. So you're going to create a database. You're going to set it up. You're going to connect it to wherever it needs to get the data. It's going to start pushing the data into the database. You need to maintain that database. You need to purge the database. You need to make sure your queries run fast on the database. You need to index your database. You need to have management plans on your database. You need a DBA to run this database for you. Now you've got another source pushing data. What are you going to do? Create another database. So you're creating these little silos. We had a podcast, and we're going to talk about the podcasts. We had a very good podcast with a lady called Carolina Torres, and this is the best way that she explained to me what data management is. Think about data management as the plumbing in your house. I recently got a new fridge, and it's one of those smart fridges, right? It can take the water, and you can get ice. Cool. Right, so I put it in my house. How did I connect the fridge to water? I just hooked it up in the plumbing, okay? Did I go and dig another borehole just to supply water to my fridge? The point is, I'm not going to create another borehole to supply me water. So why must I create more than one database silo to provide me data or information everywhere? So what we're going to do now is we're going to go and create a proper data management solution based on the Canary Historian. It's got nothing to do with Ignition. It is a separate product. But we're going to get Canary to consume the data that we've just liberated from the Ignition edge by using the MQTT technology. So it is totally agnostic, but tightly coupled in that sense. We are going to create a database. All right, so Tebe, please go and create a database and do all the magical database things.
Laura is already publishing the data we just generated now, right? And I want somewhere to start storing this data, like Lenny said, the database. What I have here is the Canary administrator, and its job is to basically manage the product, Canary, but what we're going to use it is to create a database, which is where we're going to send the data. I'm going to go ahead and go to my historian and create a new data set, which is just another, similar to a table in SQL, right? Okay, I'm going to go ahead and do that. Call that DLF dataset. And no spelling errors, and create. And that's it. We have a database.
This is the point we want to make about creating a very simple data foundation. It should be as easy as that to create a database and to get the tags. So Tebe, traditionally, I've worked with a lot of historians in the past. I probably now need to generate a massive tag list that's going to now have addresses and names. And I probably now need to import this tag list into the historian and hit the save button, and then it's actually going to start saving my points, right?
Yes.
Okay, so you're going to create a massive CSV file.
No CSVs for me. This is so easy. What we're going to do is just point to where Laura is sending the data. So where it's being published, we just want to go collect it. So what Canary has is services called collectors, which do just that. Point to a database and then point to a data source and then get the data, right? So luckily, we have multiple Canaries on our system, and we have one installed closest to our data source. In this case, we have our MQTT broker as our data source, and we will explain what the significance for the data source is just now, right? I will go ahead and take us there. Here, we'll go to our control gateway, which is where our MQTT broker is running, and we have the data source, the collector configured. It will open the Canary services available on that guy, on the collector, and then I'll go ahead and just tell it how to get the data and where to send it, right? So I am on the broker's machine. I'm going to go to configuration, and I'll just start defining my connection details.
All right, while Tebe is doing this, let me just explain the concept of these collectors. Canary can be, from an architectural perspective, you can go and install as many of these collectors as what you want. You want the collector to be as close as possible to where the data is coming from. In a normal plant environment, you want to install that as close as possible to your OPC servers. You want to install them as close as possible to your MQTT brokers. Multiple of these collectors can then collect data from these sources and push it to one data set. You don't pay for the amount of collectors you have. You can have as many of those data sets as what you want, data collectors as what you want, pushing to your data set. You can even have those collectors pushing to multiple data sets. So you can create a nice high availability network that way. So what Tebe is doing now, he is just pointing the MQTT collector to the same MQTT broker that Laura is pushing the edge data to.
And each one of those Canary collectors also natively have local store forward capability for added redundancy.
Right. Important thing that he's doing here, he's also enabling the Spark-Plug-B protocol. So what that will allow Canary to do is to say, hey, when there's a new tag, I know there's a new tag. And it will miraculously auto-populate all of these tags and start historizing the data. So he's not going to create a tag.
When I go ahead and apply, I finished configuring what I needed to. And now, if I go back to my data source, I will have a data set that tells me how many tags have been historized. One more thing that's important, I actually have to activate the connection. Go back there, go ahead and activate the connection. Okay, cool. Just need to enable.
Before you go, click on home for me.
Okay, home.
All right, so the sender service right at the end there is busy sending some data. It looks like it's active. Let's go see if it works.
Okay.
There we go, DLF data sets. We can see there is tags writing. It's created a block for us. And there's all the tags. All the tags from our brokers created in this historian.
Click on one or two.
All right, now you guys can start to see why it's so important to model at the edge correctly. Because that name structure that you're going to decide on the edge is what Canary is going to automatically create because of the birthing of the Spark-Plug node. We've got data, it's storing, it's historizing, and I can now use that historical data to go and answer some questions.
And also consider the redundancies that you can build with multiple brokers. Like we're thinking about one broker right now. Think about the redundancy that you can build across your entire enterprise with multiple brokers.
I have a quick question though. What's going to happen if there's load shedding? Because you just connected one Canary to another. What's going to happen?
So remember we said it's important to always get data closest to your data source, right? So because we have the collector running on the data source, whenever we lose connection between the two data servers, the collector will start buffering the data.
We're not as brave to pull a network cable for the demo. So what we're going to do is we're just going to stop the historian's receiver service. Okay, so what this says is, I've got the collector closest to source. It's talking to the historian and say, hey, are you available? Yes, I am. I'm going to start pushing my data. We're killing that service on the historian. Okay, so we're technically telling this collector, you can't see the historian anymore. Please go into local buffer mode. So that's what Stereo is going to do now.
Okay.
Going to go to the services, and he is just going to stop that receiver service.
Over here.
So just simulating that the collector at the edge can no longer see that point. Okay. So this is also a cool thing about the Canary admin tool. You can, from one central place, manage all of these different components in your Canary historian. So he's just using that little drop down at the top right there to navigate to all the different collectors and services that he's configured on the different nodes in the architecture.
Now what we should be seeing is on our gateway, where we have our collector, we would see the buffer start building up. So you'll see it's 7,000 right now. It's going up and up and up. That just means that we're not sending data at the current time, right? We're not seeing where we're sending it.
So this buffer will buffer until there's no more space on your drive. Doesn't matter how long, it will just keep buffering and buffering and buffering. Tebe.
Okay.
How many tags is in the buffer? It's always amazing to me for the little, we've got 10 meters, right? Pushing data. It's not even been off for 10 seconds, and we already have over 1,000 points being buffered.
29 tags in total at the moment.
Yeah, it's always mind-boggling to me how many data points we in the industrial world actually generate.
So to give you an idea on the Canary, I'm not sure about other databases. So Canary, if we're talking at about 10,000 tags every millisecond, for a period of a year, we're looking at about 1 terabyte. For a year's data, 10,000 tags, which I believe is fairly light.
Right, how fast can the Canary do? The Canary can read tags out of its database, 2 million in a second tags. Tebe, just go into that data set. Okay. Let's look at those tags.
Here's our data set. Here are our tags.
What we're going to do now and this is something that is quite very important, is in Canary we've got a way to give structure to these unstructured tags. And we can even do it in such a way that we can go and define assets. So I can go and look through all of these tags, and I can go and define what does a power meter tag look like, and it will automatically go and generate power meter assets, water meter assets, and my HVAC assets. And if I look at this lens into the historian from an asset view, then it's much easier for me to answer that question.
Before we continue, I want to go back to my data source and quickly adjust the name here. And that is because so Laura would have created those tags earlier on, telling me where to save the data. Just the name has to be correct so that you can remember, so it can show up with your tags as well. So you have to tell it exactly where you're going. It's just that connection needs to be configured correctly. So this guy should be Modbus. Okay.
Oh, that was my device connection name.
Yes. That's what she called it. So I'm telling it this is the Modbus data. Now that's sorted, I can now go and show you how to actually sort out your tags, right? So we are in our historian, still collecting data, all working. Okay, now I am going to go home and go to a service called views. And this is where I am going to now try to logically make sense of the tag names. Like Lenny had mentioned, you could have multiple tags and you want to make sense of how they are, right? So you'll see there is DLF view. I am going to select that. And you'll see there's multiple tags in there. So to actually configure it, I'm going to go ahead and click on the drop-down and say Edit. You will see there's a few instructions there under the Match and Replace column. This is just to say, whenever in my tag name I see this specific string, replace it with this or format it this way. This would be helping you to rearrange the tag name and resolve the issue where you have existing tags that come from one system with a different naming convention because they were configured some time ago, and then now you have some other tags that are now newer or they were built with a different standard and you want to make sense of all of them.
So all these rules that you are seeing on the virtual view screen, they are built out of a regex language, right? So it's technically a string manipulation language that Tebe is creating rules with to take the tag naming structure of the different tags and kind of filtering through them, creating assets and just making it more human readable. And the whole idea is, this is a virtual view. It's kind of like putting on glasses and it changes the way that you look at things. So this is not altering the names of these tags in the historian. It's not changing how the raw data is being saved or changing the tag paths.
You can, in your organization, create multiple of these views and give access to certain people to certain views. So if you've got the energy department, they will only see their energy stuff. If you've got the engineering guys, they might have a different view that sorts and structures the tags in the way that they want to see it.
So over here, we have all the tags that we've built. So as you build the rules, Canary has a preview for you at the bottom there. So in this case, these rules were busy building the namespace, basically. So wherever it saw DLF facilities, utilities, it would replace it with DLF, and so on and so forth, right? So now I see my tags have multiple sections. What I want to do is to now add HVAC as an asset. We have a concept called assets here. And an asset, it is basically a way of grouping tags together that are related to each other. So you would have a meter, and they would have a PV, and they would have a set point, and this and that, right? So you want them to have a logical relation between each other. So I'm going to go ahead and add my HVAC. So right now it's just the list. It's one of the many tags that I have. But you will see as soon as I finish building the rule here, that will show up. So I'm going to go ahead and click Add and tell it that I want to create a new asset rule. I'm going to look for any tag that has the word HVAC. And then I'm going to call it an HVAC asset. Click OK.
So that's how easy it was to create an asset.
And now it will tell you how many matches it found, and then you go ahead and apply. I'm going to do the same thing for lights. I want to do some statistics on the lights, or I want to group them together. That might be if they are the count that are on, and so forth, right, depending on what you want to build. So I'm going to go ahead and say lights, go to asset type, lights. So it's doing a find and replace. So now you'll see some of these tag counts have changed. And if I click apply and go to my DLF, go to my specific region, in this case Cape Town, auditorium, I will see now I have an HVAC Before we just had one tag, and now all of the other tags that matched with HVAC are included in this asset.
If you add any more tags into your data set, and the rule will find that it's an HTAG tag, it will add it automatically to your HVAC lists. The rules and the views dynamically scans the data set, see if there's a match to whatever I've configured based on the regex patterns, and it will automatically add it. So if I spin up site C, another greenfields building that I've bought, I hook it up. If the rule can find it, that asset will automatically appear in the asset list. Okay, Tebe, how do I now use these assets to build a very cool, quick dashboard so that I can answer that question? Which of my 5 buildings are using the most power?
So now we have our data organized the way we want it. We want to visualize it and make sense of it and answer the question that Lenny asked, right?
So this is what Axiom is. It is the client tool, part of Canary. Axiom clients are included unlimited from the beginning of January, as well as Excel add-ins.
Right, just create a new application just very quickly, just show them how we select the asset, and then we can show the pre-built one that we've got.
So now what I'm going to do is click New and say I want to drag in an asset template. Now what an asset template does is say, in this one block that I'm building, I want to use these tags, right? This set of tags. So as I'm building, it will know whenever I see in other parts of my model with the same tags, it will create the same template, but for that specific part. So I might be creating data for Cape Town once, but it will pull up everywhere else that matches, like Durban or Joburg, right? Okay, I'm going to go ahead and say HVAC and click Apply. Okay, I have a blank screen, don't worry. I'm going to drag in a label. You'll see already we have a bunch of assets that were identified, and you'll see as I build the label, it is adding the label everywhere else, right?
We're moving away from creating predefined trends by creating dashboarding and trending based on asset type. Okay, so it automatically identified this 5 or 6 or 7 HVAC machines that I've got, and now I can go and add a trend, click on the assets trend type or tag, and it will go and build it out for me. Right, Tebe, let's go to the predefined one that we've built already.
So I had one that's predefined here. I'm going to click on Open. There we go.
So Tebe created this based on that exact same view a little bit earlier. It is a much nice, sexy dashboard, so it's going to go and find out all the different types of assets. It's going to go and populate the screen based on the amount of assets that we've got. There we go. And it's going to start pulling in the data for the different asset types.
So all I did here, same asset template, I put in everything, and then whenever I build in one block, it automatically brings up everything that matches. So you'll notice this is also for all of the other parts, all of the other sites that we had identified.
All right, Tebe, quickly. Top 5 power usage building.
Okay, first of all, I need to find out all the power usage tags, right? So I want to say this is power.
While he's doing that, this is pretty cool. This is like a built-in filtering that you can use to check out all the assets.
I'm just looking at my tag here, the tag name.
Funny.
This is power.usage.pv.
Cool.
Okay. And I want to open this guy.
No, you just finalize your expression. That's
okay, .pv.
Okay, so if that's great, show me everything where the power current drawn is greater than 800.
Okay, so I'm just going to say greater than 800. Okay, let me just leave the editor here.
All right, so there are the ones that are greater than 800. Now sort them by the top 5 usages.
Okay, and I just say sort by top 5.
All right, so you can sort by the tags as well. So in this case, we're just going to sort by the power usage tag as well. So we sort by the power usage tag, and we say, please just bring back the top 5 after that.
There we
go. There's your top 5 energy usage buildings.